Now, I mentioned that you can always know for sure whether a reaction is going to the left or going to the right by understanding the relationship between Q and K. And this here is a nice picture of that in action. Notice that what I have here is in the middle my equilibrium location on this graph. We know it's at equilibrium because the amount of B and the amount of A are not changing. Their ratio, B over A, which is Q, is a constant and is equal to my equilibrium constant, that value that's sitting there in the back of my book that I look up. As I said, there are two ways to get to Q equal to K. You can either start with a lot of A and no B, or you can start with a lot of B and no A. But either way, the reaction ultimately has to progress to this point here. Is there a general rule about what Q looks like relative to K when you have too much A or too much B? And the answer is yes. By looking at that ratio, you will always notice that if you have more stuff on the left side than on the right side, then Q is going to be less than K. And that means the reaction necessarily has to move to the right. If you have more stuff on the right side than the left side in that ratio relative to K, then the reaction has to move to the left. So you have this nice little sort of rule of thumb here. Q less than K, move right. Q greater than K, move left. So if I show you a number like this, K is equal to 3.8, and I told you I've just done a calculation where Q is equal to 2, you'd go, oh, Q is less than K, the reaction is going to have to shift to the right. If I show you, on the other hand, that Q is equal to 3.9, even though it's not that much more than K, it is greater than K, and therefore the reaction has to shift left. So keep that sort of little mantra going in your head for the rest of the semester. Q less than K, shift right. Q greater than K, shift left. Q equal to K, you're at equilibrium.